Okay, in this part of the video, we'll be evaluating exponential expressions that have negative bases. Now, I want us to recall, first of all, recall that, for example, that 2 to the fourth, okay, is the shorthand of saying, is the shorthand or shorthand way of writing 2 times 2 times 2 times 2. In this, the expression, the exponent is 4. So 4 is the exponent and the base is positive 2. In the next example, we will evaluate exponential expressions with bases that are negative numbers. So remember, let's mark this out again. If we have a number here to a power, the b is the exponent, the a is the base. We will be working, zoom in there, we will be working with this base being negative. Okay, we'll still keep the exponent there. So let's start with some examples. Our first example will be to evaluate each expression. All right, so when we are going to evaluate each expression, we are to think of them this way: the base and the exponent. Still keep that in mind. So our first one will be negative 2 to the 5th power. Okay, and we're gonna write the next one here on the side. Let me put it here on the bottom better instead. Okay, so let's do our first one. Do we have a strategy for solving this? Yes, we will write each exponential expression as a product of repeated factors. That's a key part right now. And then perform the multiplication. This requires that we identify the base and the exponent. So identify the base and the exponent. Okay, this is the base, this is the exponent. Negative 2 is the base, 5 is the exponent. The exponent is telling us that the number of times the base is to be written as a factor. That is what the exponent is telling us. Okay, so the 5 tells how many times it to be written. The negative 2 is the base. Okay, so keep that in mind. So the 5 is the number of times it is going to be written, or times, and negative 2 is the base. Right, so our solution to this problem is as follows. So let's put equals here. We read this to be negative 2 raised to the power of 4, or to the 4th power. So negative 2 is raised to the 4th power. This is read, 5th power. This is read as to say negative 2, and we put 5th here, and that is read as negative 2 raised to the 5th power. So that is how it is read. Negative 2 is raised to the 5th power. Okay, because remember, the 5 is the exponent, the negative 2 is the base. So then let's expand out. So we can write this as to say negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Okay, that amount of times. Now we write the base 2, or the base here, as a factor 5 times. Okay, so we write it down. This is the amount of times. So if this had 3, you're going to write it 3. If this had 7, you're going to write it 7 times to start off with. Okay, now multiply the first two negative factors and the last two negative the last two negatives, or the second two sets of 2's, and so forth. So you will decide how to multiply them out. In this part, we're going to say this: the first two multiplied, well, we can recall that two negatives multiplied with each other will give us a positive value, so this becomes positive 4 times the negative 2 times negative 2 again gives us a positive 4 times negative 2. So we are left with a negative 2 at the end. Okay, don't worry about that piece. We're going to multiply again two numbers which are the same sign, and we end up with positive 4 times positive 4, that is 16 times negative 2. Now we have a positive times a negative, so we recall the rule for multiplying two different integers or two numbers with different sign. We have a positive times a negative, that is going to give us a negative 32 in this case. Okay, so let's go back again. We have negative 2 raised to the power of 5. We're going to write out negative 2 that amount of times. In this case it was 5 times. Okay, then you're going to multiply the first two values and the second two set of values, or you could have multiplied the last, skip one and then multiply the last two. That's up to you how you want to work the modes. But remember, we usually start from the left going towards our right. Then we end up with 4 times 4 times negative 2. We said 4 times 4, that gives us 16 times negative 2, which gives us negative 32, and that's our solution for that particular problem there. So now we go to our next problem. We have negative 5 to the second power. I wanted to note here that this was an odd number of power. This is an even number of power. So this is read as negative 5 raised to the power of 2, or to the second power, or simply squared. Alright? So now we go and expand out again. We put negative 5 times negative 5, and we end up with, well, two negatives multiply with each other, that gives us a positive, gives us a value of 25. Alright, and that's how we get that answer there. Let's go with the next one. C. We can say negative 1, and sometimes you will end with a negative 1 raised to a power of 7. This is raised negative 1 raised to the 7th power, or as the 7th power of negative 1. Note that the exponent here is odd. Here the exponent was even, here the exponent was odd on the first example. Okay, so when we expand this out, we end up with negative 1 times 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 negative 1 and times negative 1. Okay, we write the base as negative 1 as factors 7 times, right? Because that's the amount of times you have up there. So multiply the first two, we end up with positive 1. Multiply the second two, we end up with positive 1. Multiply the third set of 2's, positive 1 times negative 1. Then we multiply these two ones, that gives us 1. These two will give us negative 1. Then multiply two numbers with different signs, we end up with a negative 1. And that's our solution for that particular problem there. So therefore, you can see again, I'm going to write this out, this note, that even and odd powers of a negative, and this is very important. The reason why, it speeds up the process in solving the problem. If not, you will always, for example, if you had negative 7 to the 7th power here, instead of writing that negative many times, just simply know that since it is odd, you know the solution will be odd, or will be negative if it's negative in here. Okay, so these are the shortcuts to this. So we're gonna write now, when even and odd powers of a negative integer, when a negative integer is raised, for example this one here, negative integer is raised to an even power, as in example B, we end up with this here, even power, that's an even power. Okay, the result is positive. Okay, so when you multiply negative integer raised to an even power, the result is positive. When a negative integer is raised to an odd power, the result is negative. Okay, so that's how we work that out. Nothing should be complicated there. Now remember, this is bracket, the base is in the bracket raised to the power. So let's try some other examples when negatives are raised to a power. So example, we have here evaluate negative 2 raised to the power of 4. Okay, our strategy here is to rewrite the expression as a product of repeated factors, which would then be negative 2 and so forth. But remember, this negative is not the 2, the negative is in front. We must be careful when identifying the base here. It is 2 and not negative 2. So here base is not negative 2. Base here is 2. Key points there. Alright, in this case the base is not negative 2, it is just 2 as the base. Since there are no parentheses around the negative 2, then the base is 2. Right? If this had parentheses, then the negative 2 would have been as the base. So then we rewrite it. We put negative 2 to the 4th power. Sorry, but that's supposed to be minus 2 to the 4th power. And then this will be expressed as negative, open bracket, 2 times 2 times 2 times 2. This gives us negative 2 times 2 gives us 4 times 4. This gives us negative 16. So therefore this is our solution for this particular problem here. So remember, in this one here, the negative or the minus is outside of the 2. The minus is not part of the base, compared to the previous problem which we just did when we had brackets. When we had brackets, that forms part of it.